Good. All right. So here's the thing. Yesterday we talked about this, that a logarithmic function and an exponential function are inverses of each other. Now this is what you're really going to use starting today. So it's really, the presentation is real simple. It says to you here, g of x is equal to log base b of x, and that is the inverse of f of x equals b of x, right? Okay, so this is simple. Look at example number 1. Y equals 6 to the x power. Okay. So here we go. Just look at the guide up here on the board and tell me what's its inverse going to be. Y equals what?
ln x plus
Okay.
6.
All right. It's not going to be ln. It's going to be log. Okay. Okay. Log of what now?
Log of 6x.
There you go. You got it. Okay. Y equals log base 6 to the x. Is exactly right. That's the answer. Okay, now that's real basic and simple, and they are real basic and simple if it starts off like this, right? If it starts off as a basic one. The problem is when you put additional stuff on the side of it, okay? That's when it gets more difficult. Okay, so here comes the second one. Here comes B. Y equals ln of x plus 3, right? All right, so here we go. The first step, and this is very step intensive, as you'll find out. The first step is you gotta trade the x's and the y's. Okay, you learned that earlier in the year. Right? When you find inverses, always step number 1, trade x's and y's. Okay, now here comes the second part. The second part is that we don't know the base of ln. But we do know it. We learned that yesterday. What's the base of all ln's? Nope, that's for log, but this is ln. That's natural log. Okay, yeah, it's e. Right, very good. Ln means natural log. That's what you learned yesterday. Okay, it's e. Right, very good. Okay, the base of all natural logs is e. Okay, now this should look familiar to you, right? Okay, this is what you guys did yesterday. Oh my gosh, I got to change that and make that into exponential. Okay, so what's the first thing you do? You drop the log, drop the ln, drop the log. Okay, so the first step is drop the log. Okay, then what's the second step? You switch, right? Then you make the switch. Here comes the switch. Okay, so what are you going to write down? Y plus 3 equals e to the x power. That's right, good. Okay, now you got to get y by itself. So what we do next? Subtract the 3 from both sides. So now subtract the 3 and subtract the 3, and you get your final answer. Y equals e to the x, and then a minus 3 on the side. And that's the inverse of that. Y equals ln of x plus 3. Okay, now look at this. This makes total sense. Look, when you start off logarithmic, right? When you start off with a logarithmic, you end up as an exponential, And when you start off as an exponential, right, you end up as a logarithmic, right? Okay, and that's what you just got to remember that. When I start as a logarithmic, I end up as an exponential. If I start off as an exponential, I end up as a logarithmic. When you do inverses. Okay, all right, so now here comes the thing. I'm asking you to go graph this. Log of 3 to the x, right? Log of 3 to the x. All right, so you guys got the graph? Are you good? Just go and punch it in the calculator. Log 3 of the x, right? Log base 3 of x. Okay. Oh, that's interesting. There's a hard lesson here. All right. So if I'm going to change this to being exponential, you would make this into y equals what now?
Log.
No.
Y equals 3 of x.
There you go. 3 to the x power. Exactly. That's what you just learned a second ago.
Oh, you take the log.
Okay. Now what you're going to do? Now what you're going to do is you're going to make and put that into y equals. Go put that into y equals and go graph it. Okay, I'll put that in the light, let's go grab it, right? Okay. All right, now, go look at the table. Go look at the table. All right, now you tell me this, okay? When x is 0, how much is y? Good. When x is 1, how much is y? When x is 2, how much is y? When x is 3, how much is y? That ought to be enough. Okay, you got that. Okay, now, here's the thing. Are you going to put those points on the graph?
No.
No, you're not, because those are the points. It's the inverse of those, that's the points. Okay? All right, so let me tell you this. Now, and you guys learned this in geometry, you also learned it this year. When you have these points and you want their inverse points, what is it you do with these coordinates?
Switch.
You switch them, that's right. You switch them and trade places. So I'm not going to graph 0, 1, I'm going to graph 1, 0. You got it. Graph 1, 0. I'm not going to graph 1, 3, I'm going to graph 3, 1. Right. 1, 2, 3, and 1. I'm not going to graph 2, 9, I'm going to graph 9, 2. 9, 2. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 2. You got it. Okay, and that's enough to do this, right? All right, now let me ask you this. Is there an asymptote with this? Yes, there is. Yes, there is. Okay, so what's the asymptote? Is it the x-axis or the y-axis? The y-axis, that's right. Okay, so you're going to draw this thing, hugging the y-axis, comes up, hits this point, turns like this, right? Goes up like that. There you go. That's what the graph will look like. Something like this, right? Well, okay, all right. How do you know that there's an asymptote there? Well, because of the fact that there are no negative numbers, you see, that show that there is a y value. Is how. Well, once again, you didn't see that yet. In a second, you'll understand. All right, now let me ask you this: what's the domain of this? No. What's the domain?
0,
Okay, and curvies or straights? Okay, curvies is right, very good. So 0, infinity, curvy. Good job. Okay, now what's the range of this guy? Negative infinity, positive infinity, curvy. Good job. You guys got it. Negative infinity, positive infinity, curvy. Okay, so we did that. Okay. All right, now let's go to the next one. Here we go. All right, here goes the secret formula you can use. Now watch, and this is not on your notes, so you're going to write this carefully. Y equals, okay? And here's what you're going to do. You're going to draw a fraction bar like this. On the top of the fraction bar, you're going to put log. On the bottom of the fraction bar, you're going to put log. Okay, now look over here at this, right here. Look at this. There are two things. The x is on the top, the 1/2 is on the bottom, right? One's on the top, one's on the bottom. So I'm going to write down what? Log of and log of. That's the formula you have to use. Go type that in the calculator now. Go type in y equals log of x, close the parenthesis, divided by log of 1/2, close the parenthesis, press enter, and suddenly you got the graph. That's the graph. Okay, now, when you're looking at the graph, okay, go to the table now. Okay, now you tell me this. At 0, I get
error.
okay, which means what?
It doesn't touch it.
That's the asymptote. At 1, I get
0.
okay, so that I do have a point. And 2, I got negative 1. Okay, and 4, right? I get what? Negative 2. Very good. And 4, I get negative 2. Okay, and 8 is it? I get negative 3. Very good. Okay. Okay. Do I have another one I can put on the graph or no? No, I don't. Okay, sorry, I'm ready to draw this thing. Okay, so you see what it's going to look like. Let it hug the asymptote, come down, get the critical point, turn, and there it goes. Okay, See, it's easier to do it this way. Okay, now tell me the domain.
0,
0, infinity, curvy's the straightest. Curvy, good. Okay, now tell me the range. Negative infinity, positivity, curvy. The nearest for all, it's gonna be that way, yes. All right, for the range, right. Okay, is everybody good so far? All right, yes, it does look right, okay? Okay, now, here we go. There's an asymptote. Where's the asymptote? And you don't know, go, -3 is right. You can go to the table and see where error shows up. So it's at -3, yes? Okay, so 1, 2, 3. -3 is right here as your asymptote. Very good, it's correct. Okay, all right, now you, okay, and -2 I get 1. And -1 I get 2. What's my next point? At 1 I get 3. And I think there's one more. At 5, is it?
Yes.
I get 4. Okay, now is that enough to graph it?
Yes.
You're ready to go. Okay, so go down, go over here and hug the asymptote, right? And come up and hit the critical point. Turn the corner. There you go. It's like that. No, it's not. Not with this trick, it's not. It's really easy. Okay, all right, now what's the domain going to be?
-3.
To infinity, curvy. And then what's the range going to be? Infinity, positive, curvy. You got it. There you go.